In the September 1977 issue of Mother Earth News, a retired engineer published a set of plans for a device that could heat any room in America for free using nothing but old glass bottles and scrap wood. The plans cost 75 cents with the magazine. That device quietly heated thousands of homes through the winters of 1977 and 1978. Then the energy crisis ended, oil prices dropped, and the plans went back on the shelf. They have been sitting there for 48 years. I found them last month. What you are about to see is not a theory. It is not a prototype. It is a working system that produces 140 degrees of free heat even when the temperature outside is at freezing. And I am going to walk you through exactly how to build one this weekend for somewhere between $0 and $30, depending on what you already have sitting in your garage. And stay with me until the end, because I am going to show you one specific modification. The 1,977 plans did not include something I only learned after spending time with Amish builders in Holmes County, Ohio, that increases heat output by over 15 degrees without adding a single component to the build. I have never seen it mentioned in any solar guide, any homesteading book, or any video on this platform. Not one. Here is the thing that bothered me most when I first read those original plans. It was not complicated. It was embarrassingly simple. And the moment I understood the physics behind it, I could not stop asking myself one question. Why has nobody ever told me this before? The answer has nothing to do with the technology. The technology has been documented, tested, and published since 1977. The answer has everything to do with who profits when you don't know it. A glass bottle painted flat black does two things at the same time. First, it absorbs solar radiation and converts it directly to heat. Flat black surfaces capture approximately 95% of incoming solar energy is less than #0. 4# is greater than. That is not a rough estimate. That is a physical property of black surfaces confirmed in laboratory measurements for over a century. Now contrast that with white surfaces, which reflect back roughly 95% of the same incoming energy and convert almost none of it to usable heat. The second thing the glass does is even more important. Glass allows sunlight to pass through on the way in, but it blocks infrared heat from escaping back out. That is the greenhouse effect, and inside a sealed collector box, it happens at the scale of a single bottle. The heat builds up inside faster than it can leave. A standard 4x8 foot panel receives approximately 32,000 watts of solar energy on a clear day. The glass bottle system converts more than 25,000 of those watts into usable heat. That is better than 80% efficiency. Now here is the number that should stop you cold. Solar photovoltaic panels, the ones every energy company, contractor, and big box home improvement store has been pushing for 20 years, are approximately 20% efficient. 1/5 the average residential installation costs $15,000 to $25,000, requires permits, licensed installation, and produces electricity that then has to run through an inverter and a heating element just to warm your home. You are converting sunlight to electricity to heat, each conversion losing energy along the way. The bottle collector skips every single one of those steps. Sunlight becomes heat. That is the entire process. 4 times more efficient, $30 or less in materials, no moving parts, no maintenance visits. In 20 years, nobody recommended it, nobody mentioned it, and that silence has been going on for 48 years. I want to be precise about something here, because this audience deserves precision. There is no secret meeting where executives decided to hide this from you. There is no banned document. That is not how this kind of suppression works, and frankly, that version of the story is too simple. The HVAC industry in the United States generates approximately $150 billion per year. Utility companies collect hundreds of billions more on top of that. Both industries are built on a single assumption that your home cannot heat itself and that you need them to solve that problem for you. When that assumption holds, the revenue flows. When it breaks, It does not. The contractor who walked through your house last winter and quoted you $6,000 for a new furnace was not lying to you. He was telling you everything he had been trained to tell you. The training programs that certified him were developed and funded by manufacturers who sell furnaces, heat pumps, and photovoltaic equipment. The bottle collector was never part of the curriculum because it was never part of the revenue model. Mother Earth News published the plans in 1977. They called the device the heat grabber. The article is still on their website right now, free to read. It has been free to read since the Carter administration, 48 years of availability, 0 mentions from any professional in the building, HVAC, or energy efficiency industry in 4 decades. Not one contractor, not one energy auditor, not one utility rebate program, 0. That silence is the story. Now let me show you how to actually build this, because the construction is genuinely simpler than almost anything else you will find on this channel. You need a wooden box, 4 feet by 8 feet, roughly 4 inches deep. If you have scrap lumber in the garage or barn, this costs nothing. If you need to buy it, you are looking at $10 to $20. You need glass bottles, beer bottles, wine bottles, sauce bottles. Size and color do not matter much, though darker glass absorbs slightly better. You need enough to fill the box in a single layer, which is roughly 40 to 60 bottles. You need 1 can of flat black spray paint, $5 at any hardware store. You need a clear front cover. An old storm door pane works perfectly. A sheet of polycarbonate from a home improvement store costs $15 to $30, or you pull it from something destined for the trash. That is the entire materials list for the collector itself. You paint every bottle flat black. You paint the interior of the box flat black. You pack the bottles tightly in rows inside the box. You cover the front with your clear panel, sealed around the edges to trap the heated air. Then you cut 2 holes in a south-facing exterior wall, one low, about 6 inches from the floor, for cold air intake, and one high, near the ceiling, for hot air output. You mount the collector flat against that wall at a 45 to 60 degree angle, lining up those 2 holes with the collector openings. That is the complete system. No pump, no wiring, no electricity of any kind required. The physics runs the loop from there. Sunlight heats the air inside the collector, hot air rises and pushes out through the top hole into the room, cold room air pulls in through the bottom hole to replace it. The cycle runs continuously as long as the sun is shining. The moment clouds arrive, the airflow slows. The moment the sun returns, it starts again. Builders who have instrumented these systems with thermometers report output air temperatures of 140 degrees Fahrenheit when the outside temperature is 32. That heat is entering your room continuously, for free, for as long as the sun is up. Now, if you already own a house and you are thinking this is only for people building from scratch, stay with me, because this next part is specifically for you. I hear the same objection every time passive solar comes up. People say their house faces the wrong way, their walls are already finished, they cannot cut holes in their siding without permits and contractors. Here is what is actually true. The window-mounted version from the original 1,977 plans requires no wall penetration whatsoever. You mount the collector directly over an existing window. The window itself becomes your intake and output. Cold air flows out through the bottom sash opening, circulates through the collector, and warm air returns through the top. When winter ends, you remove it and store it flat in the garage. No permanent modification, nothing structural, nothing that requires a permit in any jurisdiction I have ever researched. Builders have installed these on garages, detached workshops, and basement utility rooms, the spaces that are always cold, always running a space heater, always costing money from October through March. One builder on the Instructables platform documented his unheated garage rising from 28 degrees Fahrenheit at dawn to 62 degrees by midday using 2 4x8 panels, no propane, no electric heater, no supplemental heat source of any kind, just old bottles and sunlight. If you own a home built before 1980, and a significant portion of the people watching this do, those homes were constructed when heating fuel was cheap and insulation requirements were minimal. They bleed heat through walls, windows, and attic planes at rates no modern building code would permit today. A bottle collector does not fix all of that. but it adds free heat during the hours you need it most without touching a single thing you have already built. And if you ever move, the collector moves with you. Now I want to deliver on the promise I made at the beginning, because this is the part nobody put in the 1977 plans, and it is the part that changed the output numbers in my own testing. When I spent time with Amish builders in Holmes County, Ohio, I noticed something about the way they arranged materials inside their south-facing passive walls. The Amish do not use the phrase solar collector. They do not use the phrase passive solar either. They have a much older and simpler name for what they build. They call it the south wall. And they have been building south walls into their homes for generations, long before the term showed up in any engineering program. What those builders showed me, and what I later confirmed by measuring output temperatures myself, is this. The direction the bottles face inside the collector determines how much heat the moving air actually captures before it exits into the room. Most people who build these pack the bottles uniformly. Every neck pointing the same direction, every base pointing the same direction, clean rows, organized. It makes the build feel tidy. The Amish builders alternate them. Neck pointing left, then neck pointing right, then left again, down every row. When you arrange the bottles that way, the air moving through the collector cannot travel in a straight line. It has to curve around every bottle neck. It tumbles. It creates what physicists call turbulent flow. And turbulent flow does something critical. It forces the moving air into contact with the hot glass surfaces far more often per foot of travel than air moving smoothly in a straight line. More contact with hot surfaces means more heat transferred to the air before it exits, and more heat in the exiting air means warmer rooms. When I changed my own collector from uniform rows to alternating necks, the output temperature at the same sun angle on the same day increased by more than 15 degrees Fahrenheit. In a system that already cost me nothing to build, 15 free degrees is not a small return. It is the difference between a collector that takes the edge off and one that actually heats the room. The communities that have been doing this for generations did not call it turbulent flow. They did not call it anything technical. They just called it the way that works better. And they have been building it that way for as long as anyone in those communities can remember. You did not learn a trick today. You learned that a 75-cent magazine from 1977 held the answer to a problem the energy industry has been charging you to solve for your entire adult life, and that the people who quietly kept building it the right way never stopped. If you are the kind of person who believes that real, practical knowledge gets quietly set aside when it threatens someone else's revenue, you already know what this video just confirmed. Here is my question for you, and I am genuinely curious about the answer. What is the coldest room in your home right now? The garage, the basement, the back bedroom everyone avoids from November through March? Leave it in the comments, because the next video I am putting together is built around exactly those rooms and what a single 4x8 panel can realistically do for each one, measured room by room. If you believe that what gets lost quietly can be recovered, and that the people doing the recovering deserve to know what comes next, subscribe, because what I have coming makes this look like the introduction.